So let's talk about voltage dividers today. A classical voltage divider would look like something like this. With two resistors, one looks like it's in series and the other one looks like it's in parallel. Now to put this in action, we need to add a voltage source. And that is not a voltage source. Let's give it another try. That's a voltage source. So we have some sort of voltage here. Just to make sure, let's look at it. It is 5 volts. Okay, and to add a probe, let's just add output, analog output, and let's look at the voltage over here. And to make it even more real, let's add the ground as well. So here we have 0 volts potential, and here we have 5 volts potential. Let's see what the voltage divider does. I'll add 2 more analog outputs to here and here, and show voltage and show voltage. So we can see we have 0 volts at ground, we have 5 volts at the supply voltage level, and we have 2.5 volts between the two resistors. So let's change the values of the resistors. Let's change them to 10 kilo ohms both. Then here and then here. We still get the same values as before. 0 at ground level, 5 at supply level, and 2.5 between the resistors. But we also noticed that the voltage between the resistors changed. So let's see how does the voltage change between the resistors, and let's add current probe over here so we can see the current that's passing through. I'll undo the changes. Let's put the resistors back to 1k ohms, and before I do that, let's observe the amperage that's going through the circuit, because the whole circuit consists of 2 resistors and the voltage supply. Everything else doesn't really matter in this circuit. So we can see the amperage right now is 250 microamps. That's because we have 5 volt power supply and 2 10 kilo ohm resistors in series. So if we divide 5 with 20 kilo ohms or 20,000 ohms, we'll get 250 microamps. So let's change the ohms back to 1k here and 1k over here, and we can see that the amperage has grown respectively from 250 microamps to 2500 microamps, or 2.5 milliamps, because now we divide 5 volts with 2000 ohms, not 20,000 ohms. So let's talk about the voltage divider part of the voltage divider. We can see that the voltage is equally divided between 2 resistors, which are equal. Let's divide it unequally. Let's put a 4k resistor over here, and we can see 4 volts over here. We call this 4 volts a 4 volt voltage drop on the resistor, because 4 volts out of 5 drop on this resistor, which means 1 volt drops over here. That's because of the Kirchhoff's voltage law. The input voltage is divided between the resistance on the circuit. So let's do other tests on the circuit. Let's change it to, let's say, 8K. And we can see it divided one part over here and two parts over here. To see it a bit better, I'll up the voltage to 6 volts. Now we can see that 2 parts of 6 volts, that makes 2 volts, is on the R2 resistor, and the other resistor has 4 volts, or 4 parts. 2 parts plus 4 parts equals 6 parts of the voltage. And there's also an equation I'd like to show you, which shows that the output voltage is equal to the voltage on the second resistor in this schematic, which is equal to the input voltage times the R2 resistance divided with R2 plus R1. This actually should be a plus sign over here, not a multiplication sign. Let's see if I can change that. Let's open it up. Let's change it to a plus sign. And nope, that was the wrong one. Control Z to undo, maybe. Nope. Let's reopen it and make it correct once and for all. That was that one over here. Okay. So it's input voltage times the R2 resistance divided with the sum of the both resistors. That's a classical way to look at a voltage divider. In electronic circuits, we can look at them and the parts of them as voltage dividers as well. Many of the circuits are simplified or can be simplified to look like voltage dividers, even if they don't consist resistors or a conventional voltage source. Also, we can Google voltage divider calculator, and let's look the first one that pops up in here. It has some text for it. It has the same formula, and in here we don't have to calculate ourselves. We can just add the numbers in here. Let's say I have a 9 volt voltage source, and I want to get the output voltage of 3 volts, and I also have a 1K resistor. Let's say I'll use it in R2, 1000 ohms, or we could set it to K or mega ohms over here as well. Mega should be with a capital M. If this is a lowercase m, it's a milliohm. So yeah, don't trust everything on the internet. And calculate, and it says we need a 2000 ohm or a 2K ohm resistor to get 3 volts out of the 9 volt power supply or source voltage to get our 3 volts out. So, and internet also consists of other cool calculators like LED calculators and other, which we don't look at today. Now, just to show a different kind of voltage divider, falstat.com/circuit.js.html also has some nice examples. So here on the basic side we can see the voltage divider, and that doesn't look anything like we looked before. But here's one voltage divider, here's another one, and we are dividing the source voltage, which is 10 volts at this moment. Let's just copy and paste it to verify that. 10 volts, and also let's paste it over here as well. Or I could actually put it over here where it makes a bit more sense. And there are two voltage dividers in here in parallel. We get 10 volts out of this power source or voltage source, and it's divided equally between those two resistors and those 4 resistors. Since the resistors are equal, the voltage is divided equally, 5 and 5 volts on this and that resistor, and 2.5 volts on these resistors. A rule of voltage dividers is that the source voltage is divided proportionally between the resistances in the circuit. Now, there is one more thing. Control Z to undo and get back to the original schematic, which has moved for some reason. Control A and space and drag it back over here. There is an issue with a simple voltage divider. We use it to create sub-voltages, to use them on some circuits which have different input impedances or resistance. For example, let's say I use this 2 volt so-called power supply to drive a circuit with an input resistance which is, let's say, 1k ohm. We can see that this voltage over here has dropped, and for that matter we would need to calculate the R2 with the input resistance of the next circuit in mind. So we would put these two resistors in parallel and calculate the whole resistance of this, of this circuit, and then look at it as R2. In that case we can get the right value. So in many cases we would need to raise the resistance over here or lower the resistance over here, which would then, let's see, raise the resistance over here or lower it over here, which would then increase the voltage over here. But when we connect it to the next circuit, the voltage would drop to the correct value. Thanks for watching.